Welcome back, PlayBASIC coders. Let's check out the subdivision, the state of this stuff in PlaySoft or PS3D, as it's kind of affectionately known. The subdivision is just applied to rects at this point, or quads. Everything that's seen is transparent. It's alpha blended 50. It's pretty obvious already that the image quality of this kind of objects up close is much better than what it was before. We haven't changed anything really. We've just improved the clipping. If we get close enough to have it clipped. Yeah, it's better. Now you can really see the clipping in action. So what the user's passing in is just six faces, and the faces get divided based on their average distance from the camera, and just applies an arbitrary level of subdivision to those things. When these things are up close and we potentially need clipping, that's when it breaks down to triangles. Potentially, well, any face that requires clipping gets passed through to the clipping stage, and then that's how that works. This is not sorted, by the way. That's why I'm drawing it transparent. So see what's going on, get a pretty good idea of how it's working. It's a lot more work for it to do, and I haven't implemented all of the things from the old translate mesh to scene. They're not all in there yet. You have some clipping and some other sort of early ejection things that this doesn't have. This is doing backface removal. That's pretty much it. We have an object level clip that's occurring, so objects don't get passed through to the scene if they're off the screen, but the terrain does regardless. What I would say is you could probably, things like polymorph, you could probably do that now without doing any of the manual subdivision at all. So you could just kind of define the wall fragments and tell it to render that, and with a level of subdivision. I'm not sure how I'm going to actually make that exposed, whether it's a predefined like levels at certain depths. I fooled around with a few different ways of doing subdivision. At this point, it just seems like depth is just the simplest way of doing it. Like you can look at each polygon individually and then just try and cut them up based on their orientation to the camera. That seems to work pretty well, but you get this kind of stuttering between different division levels, subdivision levels. You know, if a face is facing you almost facing the camera, and then you slightly tilt away from it like that, you would kind of see a marked stepping of the texture. Like, I shouldn't really worry about those things. I'm not that worried about it, but it's nice that this is actually looks quite decent now, actually, as opposed to, like, it looked fine before. It was all completely affine. It still is completely affine texture map, by the way. There's no perspective mapping here. We're just using the subdivision to gain a better approximation of perspective. I'm drawing, yeah, I mean the green lines there too are, I'm actually drawing those around each polygon face. The triangles at this point are not subdivided. They're all passed through the same clipping engine, and that's actually what started all of this, is that when I went through and looked at this demo, the mouse look stuff was not working, and then took a look at this, you know, whether I wanted to expose the mesh translate to scene command. I thought, yeah, well, it's there, and demos actually use it, so we might as well have a bit of a look at it. And the clipping it used before was was all based on triangles, and it was kind of like one of the reasons why cubes look so weird as you got up near them is it would translate the quad into two triangles, and that instantly distorts the closer you get, and it pops back away as you know, as the points don't need clipping. When they do need clipping, because you've got affine mapping, it really emphasizes the level of distortion. Here we're getting away from this because the subdivision occurs on the first triangle or each face, and it cuts this down, and so as you can see here, the faces here, some only the ones near the Z plane, the near the Z plane need clipping. The other ones just are passed through and rendered, so they get to be quads. When a polygon's clipped, it can be, if it's a 4-sided polygon initially, it can be up to 6 sides. So these are spit out as a triangle fan. Well, I think that'll about do us. Just wanted to have a quick update, nothing special. It's obviously slower. We can't have anywhere near the same number of objects in scene, but we are drawing lines, and it is all transparent. So we've got about 5,000 objects. Yeah, so we've lost about 30% of our frame rate in that particular case. These are filtered triangles as well, I should point out. So you might notice as we get closer to things, they're not actually pixelated. It's one of the things that helps the terrain look pretty decent regardless. I might make it so you can tell it to render an object and not apply any subdivision to it at all. Like force the level of subdivision. I think that would give the best results. Like just doing this for everything in the scene is pretty crazy. Up close to the camera, each face, I think it's 64 faces there. No, sorry, it might be 256. No, it can't be. Each face becomes 4 new faces anyway. One of the things that the older version of this command does is it does screen space clipping. So before it would look at the triangle here and go, are you off the frame buffer? We're not doing this doing that with this. So if this object is on screen, and even partly on screen, and a face can be passed through the translate to mesh to scene command, it can be subdivided, clipped, and projected, but it might not actually be on screen. Like if you look at this cube right there in front of us, the nearest one, see how some faces are on screen, but those other ones are not. Now those triangles are still, because they're in front of the camera and they're within our sort of limited frustum, to cull it just does like a 45 degree, like it's just doing a cone and going, is the object on the other side of these two planes, or the planes around the camera? And to make that work, there's a bit of loss in that too. So object radiuses are padded a little bit, and the further away from the camera, the worse that padding becomes. So you actually get false positives. You get objects that, if you look up here, that number above where this cube is, the 26, that's the number of objects that are in front of the camera, but we can only see one of them. So where are they? They're there somewhere. Crazy stuff. Alrighty, that'll do us. I'll see you next time. Bye.